Hi folks, this is Tom. Today what we're going to do is we're going to check the bandwidth of a Collins mechanical filter. These filters are used in radios to narrow the bandwidth of a receiver to keep junk from outside the passband that you want to hear stuff at. So if you've got interference that's a certain amount away from what you're trying to listen to, by putting a Collins mechanical filter in there, it will block out all the other stuff that's not within the passband of the filter. And these are very, very narrow, and unlike standard LC or inductor capacitor type filters, the skirt here is almost rectangular. So when you get beyond 500 hertz, it drops right off like a rock. They manufacture these things in many different values, or at least they used to. 1 kilohertz, 2 kilohertz, 2.5 is very, very common for single sideband. You have AM 6 kilohertz filters and even wider bandwidth ones as well. Okay, this one here is NOS. This board here was built to go into a Yaesu FRG 100 receiver. I've got the bill of sale for it here. You can see it's a model number 705, which is the INRAD number, the International Radio Company's number. And you can see that these are quite expensive. They've stopped manufacturing these, so they're starting to get fairly rare. Okay, this one here can be put into an AR5000 AOR receiver by unsoldering the 3 connections here and going ahead and then soldering into the AR5000. The 500 hertz bandwidth is great for CW or Morse code. Okay, let's get down to brass tacks here. What I've done is taken my Hewlett-Packard signal generator. We've got a 455 kilohertz. I've got a minus 44 dBm here, so what we can do is we can actually look at the old school oscilloscope and see basically how wide this is. So we're going in from the signal generator, going through the filter, and popping out on the output of the filter. Okay, let's check this out here now. What you want to do is to basically set this thing so this is full scale at the center frequency. This is theoretically 455 kilocycles here, but let's go up and down a little bit just to see where this thing has the best sensitivity. Okay, not right there. We're going up. Let's go down a little bit. Wow, look at that, right there. 454.970 kilohertz, or we're basically 30 cycles low, and that's not bad. Typically what you do is you measure these things to 6 dB bandwidth, and the cool thing is, here you're measuring voltage, here you're generating power. dBm is power, this is voltage. Well, guess what? 6 dBm is half the voltage. So here we're at full scale. So what we're going to do is we're going to look for half scale, or 1, 2, 3, 4. Okay, so now we've got center scale. Let's go up and watch what happens. There we go. Let's hit the right button. And you see now it's going down. And now it's coming up a little bit. It's peaking right there. It's going down again at 150 cycles. But watch what happens. There's a second peak here. It comes back up right here. Whoop, and then it drops off. So right now we're 455.300. So we're 300 cycles high. That's the top end here. And I'll show you what happens if we go higher than this. See, it just goes off the scale like a rock. This doesn't do anything. So we're going to bring this back down now. And you can see as we start getting closer here, it starts coming up gradually. And here we are again, 455.300. Okay, let's go down. And now we're first peak, and now we're going to the center frequency. And there we are. Center frequency 454.970, again 30 cycles low. And let's find out where the bottom end is. So it drops down, and now we're going to have a peak right here, There we go. And wow, it just drops like a rock from there. Okay, let's go to see where that peak is. Bringing it up, and there's that peak. And now we're going to go to the bottom edge of it, and there we go. That's it. And so there we are at 454.77. So if you look at that, that's theoretically 230 low, 300 high. That's 530 cycles for a 6 dB bandwidth. I'd say that's pretty doggone close. That's within 10%. So I would call this filter perfectly fine. Okay, let's go back up here and I'll show you the 3 dB difference. And then we'll call it quits here. Okay, so we're going to find where the maximum is right there, 454.97, and see we're at minus 44. Watch the scale here, and now watch what happens. And see, now here we're at half scale voltage-wise. Oh darn, look at that. We're at minus 50 dB. So going to voltage half scale, minus 6 dB. Perfect. Thanks for watching, folks.